Actually, you can also do the single stepping. You have, like, whenever you are doing some stuff, so you can do some timeline. You can do some timeline for R7. Then you say iteration 1, then iteration 2, then iteration 3, then iteration 4, then iteration 5, and you just go through all of these iterations and see the contents and do it with an example. When you will do it with an example, then you will reach to a correct. You can then write a correct program. Do it with a small example, and with this small example you can do this. Okay. Okay, now the question, how we can pass different arguments to a function G. How you can pass different arguments to a function G. Any clue? How do you pass different arguments to one function? What is a function? Function is a conditional branch instruction and unconditional branch instruction. Unconditional branch instruction. Okay. But now in a typical jump, which is an equivalent of a go to, there is no return path. There is no return path. But in a function or a jumps to subroutine, there is always a return path. Now let's assume if you are writing a C++ program, so now let's assume you have void main void. So your C program, there is some code. You need function f1. Actually, this function f1 is called. This f function is function. If you again call it function f2, then again function is called f2 is called. Okay, so now let's say if this is an instruction ik and this is ij, this is ij, im, this is it, and then your iz. And this is the last instruction, this is IY. So now you are in the main program. Where this IJ instruction finishes, the control is transferred to which instruction? IM. So after this IJ, which instruction will be executed? IJ, then IM. And IM, and so far so on, and after IM, maybe this is IN, then IN. After this, which instruction will be executed? IZ. And from IZ, then IY. From IY, the control will be transferred back to IT. And IF. After that, IF. And after IF, the control will be transferred to IK. IN. Which what? F1, IM, IN, F2, IY, IT, IF, again IK. So actually now you have some return path in a function. How this is implemented in assembly? So far in assembly, we have some instruction, we call it JSR. So now let's say we have this function f1. So the assembly equivalent of this is JSR label of f1. What is label of f1? Label is an address. Label is an address. Label is an address. Okay. Now we have a function, so now we have a label of f1. Once we have a label of f1, so what instruction should the first instruction? So actually it is label of f1. This is I m. So label f1 is actually the address of the first instruction of the function f1. Okay, now after this you have in. Which instruction will be here now? GSR, very good. GSR, label of f2. So now you have label of f2. Label of f2 is an address. So the first is the first instruction. IZ. So label of f2 is the address of the first instruction in function f2, which is IZ. Okay. When it's IZ, then you have IY. But the last instruction of this any JSR is RETI. RET. It's called as return from subroutine. Return from subroutine. So in return from subroutine, so it will then again jump to IT. And then after this last instruction, you have RET. Return. Okay. Now what's happening? Now you have when you want to jump on the function f1, when you are jumping on the function f1, so you need to store the address of ik onto the stack. Okay, so actually when your GSR occurs, okay, now there are two things. Jump label f1, in jump label f1 there is no return path. But in GSR label f1, actually the address of the following instruction. What is the address of the following instruction? IK. So actually address of IK onto the stack. So when this instruction is executed, so actually in the stack will be push address of IK. So before jumping to this function f1, label f1, the address of this instruction, address of ik will be pushed on the stack. Again, when you jump on this function f1, again here now you have GSR of f2. Which address will be pushed on the stack?
ID.
Yes. Then after that when it's there, so actually then address of IT will be pushed on the stack and the control will be transferred to here. And when it's in, once you have a return instruction from here, so it will pop the value. And what is on the top of the stack? IT. Where the control is transferred? IT. And when you come here, so IT, it is pushed on the stack. So when you have return instruction, so actually the top value from the stack will be pop PC. That will be updated in program counter. In the program counter, so now in this case you have return IY. After IY you have a return. So actually pop PC. Now PC will be pointing to this instruction IT, and that value will be removed from the stack. And stack will be pointing now to this location. Now when this instruction is in counter, what is in the stack now? Address of IK. So actually it will be pop and now it will again return to this instruction. This is how that when you want to jump on a subroutine, so the address of the instruction that is following that function or subroutine will be pushed on the stack. Will be pushed on the stack. So I will also explain this with another example. It is a simple example. Let's assume there are different students that are sitting in the class. Okay, and I am asking the name of each and individual student. What's your name? What's your name? What's your name? I can come at this point, and he has answered me, and somebody has raised his question, his hand. Okay, now there is a jump, but it's a subroutine. So actually, I will then entertain that guy. When I am finished with that guy, then this my okay, I start. Then my hand is pointing to him. When it's finished, then I again return. So this is how a function is called in C or C++, and how an assembly a C program is transformed into an assembly language. Okay, now now we are only calling the function. We are only calling the function when we are only calling the function with no arguments. No argument. Maybe when we are calling subroutine. Okay, now it's a very complicated thing. Something is very much complicated. Okay. A special care should be taken. Special care should be taken when you are calling a subroutine. Why? I will explain this very neatly. Let's assume that we have this JSR function f1. JSR function f1. At this point, we have two registers R3 and R4. Its value is 5 and its value is 3. And we say F, R9, R3 and R4. What will be the contents of R9?
8.
G. What should be the contents of R9?
8.
It may not be 8. Why? Explain this. No, not both are in binary. Sorry, hexadecimal, whatever. 5 is also hexadecimal. If you add 5 and 3, it's 8. It may not be 8. Why? Now, let at this point we have these values already stored. No. Let's assume we have this move. Okay. R3 hash 5. Move R4 hash 3. चलो जी
मेडलेब में जब हम इस तरह का फंक्शन बनाते हैं ना सर, वो आर्गुमेंट्स हम लेते हैं R3 और R4
की बात नहीं कर रहे ना, मैं आपसे कह रहा हूँ maybe okay the new okay what should be our expected value 8, but maybe it's possible that this value is not 8. Why?
Garbage value?
No, not garbage. Maybe this function, now we are jumping on function f1, so maybe function f1 is using this R3 and R4.
Yes.
Maybe if this function is used move R3 hash 9. So now this function is now updating R9. There's a problem. The problem is that okay, now JSR function. But this JSR function f1 may also use this register. You don't know that they may use this register. So actually, whenever you call a function within assembly, special care should be taken that it should not use the registers
that has been previously
that are predefined values, like the working space. It should not affect the working space of register. Sometimes, if it's want to update R3, okay, what they do normally, so is update. If they want to update R3, so before updating R3, what they do? They push R3, and then perform some computation. Maybe this program contains some register R3, and then in the end they pop R3. So when you call this function f1, so what is the value of R3? 5. So R3 is now pushed on the stack. And maybe if you say move R3 hash 9, doesn't matter. You can use R3 as a working register. And when you are returning, before returning from the function, you pop R3. So actually, maybe this R3 is now updated to 9. Okay, now that you push 5 here, and then you have this register R3. R3s are now updated to 9. But when you push R3, so then you pop R3. So now what's the new value of R3? 5. So in this case, your output will be correct or incorrect? Correct. अब यहाँ समझ आ रही बात ये नहीं यार? तो it means now when you call a function, f1, you can call a function. So you say integer a or integer b. You pass two variables. So when you pass some variables, so these variables can be passed through registers. These variables can be passed through register, or this variable can be passed through stack. If you want to pass this variable through stack, you have to use push. If you want to pass these variables, you can pass these variables through registers. And it should also take care that the working registers that are used before the calling of this function should not be overwritten here. So now you have some registers, working registers here. You have some working registers here. So actually, what is the safe method? Maybe this function is being written by one programmer. This function is written by another programmer. So how they will know that what is the inside code? Maybe he will not interested in the internal program. So whenever you write a function or JSR, whatever the working register you use, you first push them on the stack, and returning from that function, then you pop them. Okay. Now this is one consideration when you write assembly language program. Another consideration: how you will pass parameters to a function. How you can pass parameter to a function. Now let's say if you want to pass this function void f1 integer a and integer b. How many values you are passing? Two values you are passing. So you can pass these values through registers. Okay. You say that, okay, now if you say that you have some register R3 and then you have some register R4 and you want to find the sum of this, so you can call it JSR sum. Okay, so you have now sum here, you add them, then you return. Then you say add R3 and R4. This subroutine assumes that two variables are passed to this function. That is R3 and R4. And how this? So it will pass these values. This is actually passing arguments through registers. Okay, now you want to pass. Now, this is one consideration. Now, if you want to add 100 elements, can you pass them through registers? Why? Because we have limited registers. If you want to pass 100 elements of the array, where you should store them? Memory. And if you meant memory, so what should we pass to the function? Address. One address. So you should initialize an address register. You pass that address register to the function. So one is passed by value, and another is passed by reference. When it is passed by value, it can be some data registers, and if it is passed by reference, it is actually an address in memory. Pointed out by which register? Address register. Now we did one example. Now we had an array in memory. And there were 200 elements of the array. And the first element was the base address. So you can pass that base address to the memory, and then using that base address, it can access all the elements of the array. So now let's assume if you do the previous example. In the previous example, what did we do? We sum how many elements? 200 elements of the array. So actually, now you can call a function JSR sum of array. So for this, you need to pass two information. Which information you need? Base address and another count. Okay. So now you can say move R3 hash count, and then move A0 hash base address. So actually now this sum of array is a function. So sum of array is a function. It assumes that the count is now in register R3 and
the base address
is in register
A0,
and then you can perform the computation. And perform the computation, you see it. So if you look at this is passed by value, passed by reference.
Pass
Passed by value. And this is passed by reference. This is passed by reference. So this is another consideration. So actually, if you may have studied in C++, passed by value, passed by reference. And sometimes when you pass by values, actually it makes a copy of that data. Maybe you have to then copy that register in some other temporary register or something like that. So there are a lot of compilation techniques or techniques that you need to consider when you are calling a function in some high level language, and how this calling a function will be translated into an assembly equivalent. It's all for today. Thank you very much.
Thank you, sir.